Okay, so you are being recorded. So yeah, so this is chapter 5. The title is Present Worth Analysis. And in fact, just to set the scene, let me switch to a laser pointer. Part 1 of this book is titled Understanding Money and Its Management. Okay, and so these are the basics that you would need to understand these engineering economic analysis type problems. And that part covers chapters 1 through 4. And so we're already done with that part, and that teaches you the fundamentals. Part 2 is more about the engineering side. So the fundamentals are very general, right? You're given a cash flow, you have interest rates, and you need to convert, right? You need to find the present value. You need to convert things from actual dollars to constant dollars and back, right? You need to know what is inflation and how we factor it in when we were making our decisions. These are just general fundamentals. In part 2, we're going to switch to, or not switch to, we're going to apply these techniques that we've learned in the previous chapters, more or less, in evaluating business and engineering assets or decisions or projects. Okay, so if you have a business project, an engineering project, how would you use the tools that we've learned in the previous chapters to evaluate them and to make decisions between them? Okay, and so you see here chapter 5, which is the chapter that we're covering today, that's highlighted. So that is part of the second part, and of course 6 and 7, which I think we'll both cover. I don't remember actually. I think there's one chapter that we skip, but I'm not sure if it's like one of these or if it's like chapter 9 or 10. In any case, so this is what we're going to be doing today and maybe in the next chapter as well. All right. And so if you remember, like the course objective, the main goals of the course, they were all about comparing and deciding between alternatives. And we said this is very common in engineering projects. You have multiple designs. They have different costs. Some of them may be economically feasible. Some of them may not be. So you need to filter them and then make an informed choice about which project you should go with. Okay, and even if someone makes that decision other than you at least need to follow and understand why that decision has been made. Okay, so this sort of part goes to that objective or those objectives of the course. So here are the objectives of this chapter, as always. We need to understand why there's a need to evaluate methods or to have methods to evaluate different projects. And this may be self-evident. This may be very obvious, right? Because, I mean, projects require money. You need to invest, and you need to figure out if the savings that you get or if the income that you get from that project justifies your initial investment, okay? So this is really, I mean, I kind of just ticked that box. I ticked this objective for you just now. So hopefully it's very clear that you need to have ways to find if something is a good idea or not. We're going to learn a procedure that is used to evaluate projects, and it is called the payback period method. And in fact, we're going to cover that today. And you're going to see it's kind of very easy, very obvious. But unfortunately, this method has some weaknesses, okay? And we're going to discuss what those weaknesses are once we, of course, go over the method itself. And because of that, we need other approaches like the net present worth analysis, so NPW, as you will see it sometimes abbreviated, to address some of the shortcomings of the payback period methods. Okay, so these are very simple, very basic, and we'll see exactly what they mean. These are a little bit more sophisticated, but in fact, it's nothing like new. We've already done stuff like this. Now we're just giving it a different name. The fourth objective is to identify different project types, at least in engineering economics terms. There are service projects, there are revenue projects. In fact, those are the only two that I'm aware of in this chapter, but maybe there are others that are out there, or maybe they come in later. But in this chapter, we have service projects and we have revenue projects, and we're going to see what those means, maybe not today, but later. And finally, we want to be able to compare so-called mutually exclusive alternatives, or projects, mutually exclusive projects maybe if you want, under different service life situations. So service life may not mean much to you right now, but we'll see what this means. We'll see what mutually exclusive alternatives mean later, okay? So we start off with a motivating example. This is like 2 pages in the book, but I'll try to give you the gist of the example, or sort of the case, the business case, if you will. So United Airlines is a big airline, or a big airliner in the US, right, along with American Airlines and Delta. the way they used to route planes was they have sort of fixed routes. So if you're going from, let's say, I don't know, from Denver, Colorado to London, you will fly in a particular way. So you will fly, for example, so Denver is somewhere here, right? If you know like U.S. geography, so you will fly maybe all the way here to Detroit, like Michigan, in the Great Lakes area, and then maybe you'll enter Canadian airspace and then fly over it toward Iceland and then towards the UK. Have a fixed route, and they've developed this somehow, right, based on expertise, prior experience, what have you, right? And then they have for each origin destination pair, maybe they have this fixed route. Okay, they were considering changing this procedure. So instead of just using these fixed routes for different origin destinations, what they wanted to do is they wanted to adopt some new flight route mapping software, where they input, for example, the origin and destination, and maybe it will route things, and maybe it's able also to adjust the routes, for example, every few months, maybe. This software, of course, I mean, it requires a big investment to purchase. I don't know, I don't remember like if they were purchasing it or if they were actually developing the software in-house. Maybe it's their own technology. I'm not sure. I don't remember. But in any case, no matter what, it requires some investment, right? And naturally, like all of these projects require investment. If it's not particularly like obvious, sometimes you just need investment because you need to train people, for example, to use this software, right? But also, I mean, if you're developing it, of course, you need to pay developers in order to develop it, and it will require time, especially since it's gonna. There are a lot of constraints and considerations that you need to take into account to develop a flight route mapping software, right? And so it's a complicated piece of technology, and so it requires a lot of work. And so naturally, I mean, there's a high investment cost. And then they estimated that after they have this software and implement it, they will save about $20 million every year. Okay, so that's just their best estimate. It's a forecast. They think that this is how much they will save every year. And the question that they're asking is it worth investing in this project? So notice here that you have some sort of cash flow, right? You know how much you need to pay today, and then you know what the expected income is every year for a number of years. I mean, it's not clear here how many years they will have this software in place, right? But let's say, I mean, they're going to implement it for 10 years maybe, or at least this figure here, the 20 million, is good for 10 years. Maybe after that, the savings reduce, for example, for some reason. Okay. In any case, so we have a cash flow, and we're asking the question, is it worth investing in this project? So here's the question sort of rephrased. Is it worth investing in this new flight routing software to save this amount, $20 million every year, say, for example, over 10 years, which is exactly what I told you, which is great. Other questions you may ask is, how long will it take me to recover my initial investment, right? I'm paying, what was it? I'm paying $100 million upfront to develop this software. How soon can I get my money back? Okay, so that's kind of an important question that sometimes you need to know. Most of the time, actually, you need to know. You need to know how soon your funds will be back in your account, for example, after paying for an investment. And also, as I've said here, we have a cash flow. So, I mean, that's kind of foreshadowing or teasing that we're going to use the techniques that we've used in chapters 2 through 4 to evaluate this project. And with cash flows, remember, we almost always need an interest rate in order to be able to move things back and forth, right? In order to find the present value or to find the future value. And so the question here is, what kind of interest rate should I be using here and to evaluate business investment opportunities? Yes, Mohammed?
We can use a present worth for a series of equal payments.
Yes. So yeah. So we'll see that in more detail, actually. But that's kind of what this chapter is doing, right? So this chapter is about net present worth analysis. That's basically exactly what's happening. You can convert this into a present worth at time 0, and then you can see, you can basically compare your inflow, your savings, with your outflow, and see whether or not that investment is going to be profitable. Okay, but in order to get to that point, so you're kind of jumping ahead, which is fine. I mean, it's great that you can see this now, and maybe I made it obvious, but we're going to actually take a little bit of a detour first and discuss this question, how long it will take to recover the initial investment, right? before we discuss sort of using interest rates and cash flows to evaluate and compare business opportunities. Okay, so today we're going to be dealing mostly with this question here, and then we'll see that that is not enough to answer profitability questions, and we're going to see exactly why. And then we're going to discuss exactly what you said, Muhammad, about finding the net present value of this type of cash flow later on. Maybe we'll get to that a little bit today, but likely it's going to be in the next class. Okay, so I've already kind of said what the point of this slide is in a way, but this slide is saying the following. If you're a customer who's taking out a loan from a bank, right, the bank is going to lend you money. And you remember how we draw that in cash flow diagrams, right? So you get some income like from your perspective, right? So if I'm going to draw a cash flow diagram from your perspective, it's going to look something like this. Right, so this is a loan maybe. So you get the money now, and then these payments are the repayment cash flows, if you will, or cash payments, and these are going to go straight to the bank, right? So you take out a loan and then you repay to the bank, okay? You can think about projects in companies in a very similar way, right? The company is sort of the bank in this scenario. It's going to lend some money in the form of an investment to a project. And then, of course, the project has some returns, hopefully. I mean, if it doesn't, I mean, that sounds like a terrible project to invest in. But if it has some returns, those are going to sort of pay off the investment, which is kind of like the loan, okay? So this slide is just saying that these two may seem very different, but really once you look at them, it boils down to cash flows, right? So a cash flow diagram, for example. Like here, it's going to be exactly the same thing, except maybe it's going to be from a different perspective or something, right? It depends on, if I were to draw the cash flow diagram from the perspective of the project, it's going to look exactly like this. So the project gets the money from the company, which is this part here, this first arrow, and then it has to repay, in a way, the company's investment in the form of like revenue, basically, right, or savings, okay? And so what that means is that I can use the same techniques, which I've kind of already said, that we've learned in chapters 2 through 4 to analyze business projects, okay? That's all this slide is saying. Looking at things in a little bit more detail, again, there's nothing new here. Suppose you have an investment project of some sort. If I break this down into cash inflows or benefits and cash outflows, okay? And this is from the point of view of the company, I guess, not from the point of view of the project. And so here, of course, at year 0, you're starting your investment, so you need to actually put down the money, right? And so that's what you see here. So this is a cost, and there's no benefit at year 0. You haven't yet started to see returns or revenue from your investments. And then, of course, in year 1, maybe you'll get well, year 1 you'll get this amount, year 2 you'll get this amount. Maybe sometimes there is cost actually, depends. In this case, there is no cost to maintain the project. We'll see actually an example in a couple of slides where we do have a benefit as well as a cost in that year. Okay, and you do the same, maybe year 7 you get this much, right? These are your best estimates. Of course, we know from chapter 2 that we can find net cash flows, which basically is nothing more than the benefit minus the cost. So 0 minus this 1.8 million gives you minus 1.8 million. And then here you see, I mean, it's really just the benefits because there are no costs. But this is a net cash flow now, right? And I can, in fact, draw net cash flow diagrams and then conduct my analysis on these diagrams, just as before. Okay, so now we're addressing the question that I brought up about how soon a company can get its money back. Okay, and so that's one of the primary concerns of most business people. If they put money, they want to know how soon those funds will be available again to them, right? How soon will they have suyula, right? So liquidity. And so there is a method that they commonly use, which is called the payback method, in order to determine how soon the money will be back. And they also use that, and at least it was very common in the past, as far as I understand, to screen projects. So let's say you have 10 different projects that are on the table. One way of quickly filtering out those projects is to maybe say, how soon will I be able to get my money back in each of these 10 projects? And then I say, for example, I will exclude projects that require more than X number of years to get my money back from further consideration. Okay? So you may have the threshold, let's say, that you use. So I want to get my money back in 3 years. So I look at my 10 proposals. If some of them get me my money back only after 3 years, so in the 4th year, 5th year, I'll just filter them out. I will exclude them from analysis. Okay? And so that's what the payback method does. And so this is really used as an initial project screening method. It's very quick, very easy to understand, very nice, but it has some flaws, as we discussed before. So here's what this approach is, sort of at a very high level. The principle, of course, or the question that it is trying to answer is how fast can I get my initial investment back? The method is actually based on cumulative cash flows, sometimes called accounting profit, I guess. Okay, and we'll see what this means. Of course, hopefully it's easier to see or you know what the word cumulative means, like tarakumi, right? So you have to see what your cash flows are, and then you look at the cumulative cash flows, and you'll use that to determine when the payback period for an investment is. And we'll see some examples. And then the way we use it to screen is exactly what I've said. If the payback period is less than or equal to some threshold, then the project would be considered going forward. If not, then maybe you can just remove that project from consideration. Okay, so this is a screening method, usually. And in fact, the threshold that you set can be very dependent, right? So the specified payback period, it may depend on the type of project, it may depend on the type of industry that you're in. For example, in technology, you may wish to set a very short or very tight payback period, because technology becomes obsolete very quickly, right? It changes a lot. So you want to be able to get your money back very soon so you can invest it in a new technology rather than waiting for 10 years to get your money back, okay? There are some weaknesses to this approach, and we will see them when we see examples, but the weakness to keep in mind, the main weakness, is that it does not actually consider time value of money. And that's kind of what this course is all about. And in fact, this is one of the main reasons why we introduce, maybe even the main reason why we introduce the net present worth type of analysis later, which, I mean, we've seen in the objectives, okay? At least, so this is in the conventional definition, okay? We'll see what that means. But generally, this approach is just very simple. It tells you when you get your money back. It does not consider the time value of money. That's all you need to know at this point. So what are cumulative cash flows? I mean, it's probably very, very obvious. It's the sum of the algebraic difference between the investment and the revenue. And we can use this to determine the payback period, okay? And of course, the payback period is the period of time that is required for the benefits of an investment to match, to exactly be equal to or more than the cost of the initial investment. So this should be obvious from the definition of payback period. And let's see some examples where things will become clear if they're not so far. So we've actually seen this example before. In fact, if you remember chapter 2, when we drew net cash flow diagrams, I think this is the example that was in the slides back then. So it's saying the following: suppose you have an investment of $10,000 that you can make. And let's say, I don't know, maybe it's a machine that you can buy or something. And this investment is going to produce uniform annual revenues of $6,000 for 5 years. Okay, so this is again an estimate of how much revenue you will get over the next 5 years per year. At the end of the 5 years, as we said before, we can salvage the machine, meaning we can sell it. Of course, it's going to be at a cheaper price, not the original price that we bought it for, but maybe you don't need it anymore. Maybe now you're moving on to other types of projects, and so you sell the machine, and so it has a salvage value. And salvage value is $2,000, right? So that's at the end of the 5-year project life, if you will. We also have annual expenses. So we have costs actually per year. So it's not just the revenue that we're getting. We have to be paying some amount per year in order to operate and maintain this project. Okay. And so we've seen before, so the question here, I guess, is to draw the cumulative cash flow diagram, basically, or to tell me, basically, at every year, what is the cumulative cash flow at that point? Okay, so we're going to get there. First step is to draw the cash flow diagram as given in the question. And so we start with a cash flow diagram that is not really a net cash flow diagram. So you see here, I put my investment I, which is this $10,000. So you see it here. I don't know why. It appears we have like a white box here. For some reason. In any case, we indicate the revenues, right? So we're going to receive $6,000 for 5 years. We're going to have to pay $2,000 $3,000 every year for 5 years, right? So that's E. And then we have the salvage value, which is up here. So that's only at the end of 5 years, and it's for $2,000. Okay, so this is just translating words into the diagram. We've seen this before. We've also seen how to convert this into a net cash flow diagram, and hopefully, I mean, this is very trivial at this point. You basically subtract benefits minus costs at each time period. Okay, so you see here income minus expenses. And so revenue minus expense is equal to 3,000. So I'm just going to indicate that every year for 5 years. And of course, I still have my salvage value at the end. Now, if I want to find the cumulative net cash flow diagram, if you will, so I don't think this should be conventional. This should be cumulative. Conventional is actually something else that's going to show up in the next couple of slides. Actually, in the next one, you'll see this word, but it has to do with the payback period, not the cumulative cash flows. Okay, so here what we see is that in year 1, let me go back here, I just have a cost of $10,000. So sorry, this is in year 0, right? So that's why I indicate 10K. In year 1, remember this is cumulative, so I have to take the sort of net cash flow of the first year, and then I add to it the net cash flow of the first year, of the year following that. And so that's why you see here I is 10,000 plus NR is 3,000. So that means I got 3,000 more. And so now the cumulative cash flow stands at 7,000. And because each year, of course, we're always getting $3,000 net, right? So NR here is $3,000. That means I keep increasing, my cumulative cash flow keeps increasing by $3,000 every year, right? Until I get to year 4. Then for year 5, remember I have this extra salvage value. And so that's why you see here the 5K jump from 2K all the way to 7K. So that is 3,000 as before, which I mean, if I extend this line is here somewhere. And then plus the additional 2,000 from the salvage value. So you can see here why this is kind of useful. Looking at the cumulative cash flow, I see here that it kind of crosses 0 at some point. And what that indicates is that now I'm sort of recovering my money from my investment. And we're going to see that in the next example. And that's what the payback period tries to determine. And so this is why cumulative cash flows are useful. And so here's an example. And here you see the word conventional. So this has to do with payback periods, not net cash flows per se. Okay, so that's why I think that was a mistake in the previous slide. In any case, the example here says you have a machine shop. All right, so this is like you can think of it as like a department or plant, right, with multiple machines, for example. I'm sorry if that is not the technical definition of a machine shop, especially if there aren't any mechanical engineers here. But generally, it's just a room with a bunch of machines. Okay. Those in that machine shop, there are different tasks that can be performed, such as machining, turning. You know, these are different names. I think we, for IE students at least, we covered these in ME 322, if I'm not mistaken, these terms, which I've completely forgotten about. But in any case, these are a bunch of machines that do stuff. And the company is considering moving them into a single multitasking machine center. Okay? And so multitasking is exactly what you would expect it to mean, meaning that it combines these different processes, maybe doing them in sort of in one machine instead of doing them in multiple machines. The ultimate goal is to do all of these operations: turning, milling, drilling, tapping, boring, and finishing the parts in a single setup. So, I mean, this sounds nice because, I mean, it may save you a lot because you're moving from multiple machines to one machine, but it requires an investment. And that investment cost is 1.8 million. And they give you the anticipated cost savings. Okay, so you know the investment and you know how much it's expected to save you. And so this is what the savings look like, but they're broken down by sort of, this is sort of an accounting, I guess, perspective, where they broke down the savings into each category. They computed what the savings is, and then here, what we're concerned about is really this number here at the end. It's the total annual savings. So this is how much they estimate this investment will save you every year. Okay, and the question is to find the conventional payback period. okay, or just to find the payback period. We haven't really seen anything other than the conventional payback period, at least. Yeah, so we haven't really. So what we need to find is the payback period. Now, so the book, this is one thing I don't like when the book does this. It sort of jumps straight into the solution, and then it says that typically in machine shop problems, so problems where you need to buy machines or invest in like machines, there are typically three assumptions that are made, and it puts this in sort of the solution, I think, if I'm not mistaken, of the problem, rather than in the actual question statement or even before that. So we know this is something useful that we need, and we're going to use it very often. And so what are the three assumptions that we take into account when we analyze machine shop problems? They typically assume a 7-year period unless you're otherwise stated. So that's why you see here, the question does not say anything about 7 years, but the book assumes a 7-year period because that is, I guess, common in machine shop analysis. Okay, so that's the first assumption. The second assumption is that at the end of the 7 years, we sell the machine and we get a salvage value for the machine. Okay, and that salvage value is actually typically taken to be 20% of the initial cost. All right, and so that's why you see here this number is a little bit larger than the numbers before. Okay, now you may be wondering about these two. Why are these two different? And that's the third assumption. So they say typically when you invest in a machine shop sort of project, there's a learning curve that comes with it. You know, I mean, and this is true of many things, so I'm not really sure like how specific this is to machine shop problems, right? As we said before, if you're implementing a new software, it requires people to learn that software. If you're implementing a new, if you have a new machine, same thing, and also you need to figure out how the machine integrates with the rest of your processes. So because there is this learning curve, that means in the first couple of years, you may not be able to realize the full savings, right? So we computed the savings to be 908,000, which you see here. In the first 2 years, in fact, you will realize maybe that this is 50% of this 908,000 value, and this is 75%. So these are typically what they assume, I guess, right? And so that's why these are less than the other ones. Okay, and this is more, again, because we have a salvage value. In fact, if I erase my pen, I think that's what's going to show up next. So here you get 50% of the annual benefit because you're still getting used to the technology. And here it rises a little bit, but you still haven't realized the full potential. So you get 75%. And then at the end, you get the 20% salvage value. All right, and so this is now what the cash flow looks like. From that, I can find the cumulative cash flow, which is exactly what you expect. This value here is at 0. I mean, it's just the same value. This value is going to be, of course, the value at 0 plus 1, just cumulative. And in fact, this is what it turns out to be. And then for this value here, I add all the first 3 all together. I get that value. I add the first 4. I get that value, and so on. Right? So this hopefully is very easy. Now, having done that, yeah, I don't want to skip to the next slide quite yet. So we see here. So when do I recover my initial investment? So I'll ask you guys that. Let's discuss, I guess. Yes, Ibrahim? I can't hear you if you're speaking. Three years, yes. Okay, yeah, okay. So hopefully it's very clear that in year 3, I'm in the positive now. So I've recovered my initial investment. All right. Now what Mazen said is actually somewhere between 2 and 3, somewhere between these 2 years. Okay. And that really depends. So both answers are kind of correct. It just depends on what you're assuming. If you assume that, remember our end of year convention? So when we said the payments are just going to arrive at the end of the year, or at least that's the way we're treating things. So we're in year 2. At the end of year 2, this is our balance, basically. And then year 3, this payment is going to come at the very end of the year. And so in that case, it's really year 3. I see this entire payment at once. And so because I have this sort of, I mean, we'll see it. It looks like a step function, basically, right? So this is my balance. And then at the end of the year, boom, I have one payment of this amount, right? And so that's why if you're assuming discrete sort of jumps, it's going to be year 3. If you're assuming a continuous payment, so if you're assuming this amount gets spread evenly across the year, then it is indeed between years 2 and 3. And in fact, we can easily find that, right? So let's assume for the, so again, if we're assuming discrete, it's just year 3. Okay, and that's the answer I was looking for, in fact, at this point. But let's assume now that this amount here is going to arrive sort of continuously over the year in an even fashion, right? So I don't have jumps. In that case, the payback period is between years 2 and 3. And how do I find that? What's a nice, easy way I can do that? Yes, Badr?
To find the monthly interest.
So we don't actually need to deal with interest here at all. Like this is just a math problem at this point. So in this case, so here, let me try to restate the problem and see if it makes things clearer. So imagine saying by dividing the cumulative over year 3. Yes, although you're missing one little tiny thing, but I think your thinking is exactly spot on. Okay. Remember, like I'll just give you sort of what I'm hinting at. This minus here. Okay, but I think your thinking is exactly right. So I'll explain first like what I'm looking for to the other students, and then we'll discuss this minus thing, right? So remember, at the end of year 2, this is my standing, right? I need to make up this amount. I need to make up this amount without the negative, 665,000, in order to hit 0 and then recover my initial investment. If I assume that this comes evenly over the course of the year, then I can do exactly what Mazen said. I can take this amount that I need to make up, but of course I take the positive part, so the absolute value, divide it by 908,000, and let's see what that's going to give me. So that's going to give me sort of the fraction that I need, the fraction of this payment that I need to make up. Okay, so in fact, if you do that, 665,000 divided by 908,000, you get 0.73. Okay, now if I'm assuming that this payment is distributed evenly over the days of the year, that means in 0.73 sort of pieces of a year, right, in roughly 3/4 of a year, I'll be at 0. I'll make up this amount. Okay, hopefully that's clear. It's basically I need to make up this much, and this is the amount that I'm getting, and so I need to find the fraction. So this is sometimes called prorating or proration. So think of it this way. Like I'll just give you another example so you can see clearly what's happening. Maybe suppose you pay for your cell phone bill at the beginning of the month, and so you always pay, let's say, 100 riyals for your phone service, right? And suppose you cancel maybe in the middle of the month. You cancel your service, and so you had already paid for the entire month. And so now, if the telecom company issues refunds, some of them actually don't. Most of them maybe even don't, at least in the U.S. But if it does, it will need to find out basically when you canceled. And let's say you canceled, let's say for the sake of example, on day 20 of the month. So that means you have 10 days that you're entitled for a refund for, right? And so the way they're going to do it is that they're going to prorate the amount. So they're going to look at the 100 riyals, divided by 30, look at what that number is. So that's going to be the amount per day, kind of. It depends on like the proration sort of units. Like are they going to use days? Are they going to use hours? Whatever. And then they're going to multiply that by 10. That will give you your refund, right? Because that's just finding the fraction of unused service, okay? And so that's exactly kind of what's happening here. This is prorating, right? We just need to make up an amount. We need to divide it by the total amount that we're making up, and then that will give us the fraction of the year, like at which we receive this amount that we're trying to make up. So by 0.73 pieces or whatever of a year, we will have our 665,000. Okay? And then of course I need to add this 2. So this is just telling me between years 2 and 3 when I receive the 665,000. And so I need to add the 2, and I will find finally that the payback period should be between 2 and 3, and in particular it's at 2.73 years. And the way we got the 2.73 is just by dividing the cumulative, which is here, of course, taking out the minus, and well, dividing it by the actual payment that I'm getting at time period 3. And that's my 0.73. There are other ways to find this, but this is the easiest way. You may think about interpolating, sort of doing linear interpolation. It's kind of what this is doing, actually, in a way. But if it helps you, like if this is not clear, maybe you want to think about just doing linear interpolation to find the point at which, so basically you have this, right? So you have time period 2, time period 3. You know your balance at time period 2 is minus 665,000. Something like this is happening, right? And then at time period 3, it's 243,000. This is the cumulative cash flow, right? And so at some point here, we cross 0. And in fact, using interpolation, you can find this exact point, and you will get the same answer. You will get 2.73 as the final result. So you can do it that way too, but this is easier. At least I find it easier. All right, so this is kind of what we said before. So this is the cash flow diagram. This is not cumulative yet. And here's the pictures. Here's what's going on, right? So here's the cumulative cash flow. And here you see the step function that I tried to draw earlier. So if you're assuming things are discrete, then your balance is going to stay the same until the end of the year. A payment arrives, and then it's a jump, and so on. And if you do this, then the payback period, of course, you just pick 3 in that case. That's when you actually cross 0, because you cross 0 here at this point. If you're assuming it's continuous, then you have, let me erase my pen. It's kind of like you're connecting these dots here, the dots at the corners. So you have this smooth, well, I mean, I'll just leave the one that's already there. Why did I try to draw a new one, right? And we need to find sort of when this crosses 0, when the cumulative cash flow is 0. So I'll draw a line here. Boom, it intersects the curve. If I've drawn the curve correctly, project it down on the x-axis, and that will give me 2.73, okay? And so this is kind of like what's happening in a picture. So that's the payback method, as simple as that. Just find me the time period at which I recover my investment. Of course, it is very simple, so that's kind of a nice thing about it. It's very easy to understand. There's nothing super complicated about it. Just use the cumulative and find the point. And in fact, if you're not doing this business of assuming it's continuous, you can just see the first positive value is here. You pick 3 as your payback period. That's it. And then you could use the threshold thing that I told you about. If your projects need to be, for example, less than or equal to 4, they need to have a payback period of less than or equal to 4, then this project is going to be selected for further consideration. If not, then if your constraint is less than or equal to 2, you're going to scrap this project. So as I said, it helps to screen out alternatives very quickly, which reduces further analysis. Unfortunately, it can produce some misleading. Why? Well, because, I mean, this just tells you how soon you'll get your money back. It kind of ignores everything that happens after that, right? Think about what's happening here. So let me erase all of this pen. I get my money back here, but you can easily construct a project that does the same exact thing, but then is a lot more profitable down here. So this says nothing about profitability. At least it doesn't consider that like in the analysis. Right? So I may have something that looks very similar in the first 3 cash flows, for example, but then after that, the profits just jump. And this number is much bigger, this number is much bigger, this number is much bigger. So clearly, even though they have the same payback period, the second one, the one I'm trying to construct, is more profitable. And so that's why just choosing a project based on the payback period alone does not give you the full picture. And so that's what this point is saying. It indicates liquidity, siyula, right? It does not indicate profitability. It also, an important drawback or flaw is that it ignores the differences in the timings of the cash flow. So it ignores the time value of money. And we saw this here. We didn't use interest. So I think, Badr, you were suggesting to use interest. So in fact, this approach is so simple that it does not use interest. And that's one of the flaws. In fact, we're going to fix that next. And again, like I said before, it ignores all the proceeds or all the income that comes after the payback period, right? So here's an example. You see here that this project costs $10,000 in terms of like the investment cost. This one is the same. They both recoup the money after 2 years, right? So that's when you get your $10,000. I should have drawn it here, right? So they both have the same payback period, exactly 2, right? Because it reaches 0 at 2. The cumulative reaches 0. Okay, but notice here, first of all, the profit here is larger. So if I were just using payback period method, then that would mean that I'm indifferent between these two because they have the same payback period. But here, this is more profitable. And also, notice here that I'm getting 9,000 in year 1. And I know from my knowledge about the time value of money that that's more beneficial to me than getting the 9,000 in year 2. Because I can invest this money as soon as I get it. For example, as always, I mean, we said $100 today is better than $100 a year from now. Okay? Or if you're using it to pay back a loan, let's say if you take out a loan for this machine, then you can immediately use that money to pay back most of the loan. And therefore, you can maybe save on the interest that you pay. Because the balance after this year, if you remember what we did in that table with the loan balance and stuff, the balance is going to be smaller. So it's always beneficial to have money upfront, like to have money as soon as possible. So this shows you that the payback period method, although simple, has some issues and has some flaws. So to that end, to try and fix some of these, we first introduced something called the discounted payback period. Now, when I say discounted, hopefully that indicates that there's some interest involved, that I'm multiplying by a factor, and that factor has interest. And so this approach tries to fix the time value of money part that the conventional payback period does not take into account. And in fact, it considers something called the cost of funds, or the interest that is used to support the project. And we'll see what that is. It's a little bit weird, I think, but we'll see what it is. And it does the same sort of thing, but it uses discounted cash flows. So basically, that's just saying it takes the time value of money into account. So the main question that this approach is trying to do is ask the question, again, how soon can I recover my initial investment, but now plus interest? So this is the new part. It's based on cumulative discounted cash flows. So this is the new part. And also, you can use it in the same way, right? For screening, exactly the same way. You have your threshold, and you filter projects based on that threshold. The weaknesses, it still suffers from the same sort of weaknesses that the payback period method suffers from. It fixes the time value of money weakness, so it tries to fix this, but it still suffers from this weakness and this weakness, right? It still says nothing about what happens after the payback period. And in fact, the only one that's going to fix the remaining two is the net present worth analysis or criterion, which we're going to see maybe next class, or maybe we're going to start it this class. I'm actually not sure. Okay, so it still suffers from that weakness. Here's an example. So take the same example actually that we've had just now, the previous example, and let's assume that the firm's cost of funds. So this is an interest rate kind of, and we'll see what this means or what the book says this means. Take it to be 15% and compute the discounted payback period. Now, initially, I was a little bit confused by the way they did things here. So I will show you in the next slide another approach, which I think is a little bit clearer because it uses the same sort of approach that we've covered, like the cumulative approach that we've covered before. I think that one is clearer, but I'll go through what the book does in any case because I think it's kind of setting the scene for the rest of the chapter, because this cost of funds business is going to come up maybe a lot. And so maybe that's why they're doing it this way. Okay, so the way you do it is the following. Period 0, you have your cash flow, which is just the investment, right? So this is the original cash flow. This column here is just copying the numbers from the previous example. The cumulative cash flow, of course, at 0 is the same. There's only one number that you need to add. Time period 1, I know I received this much. Remember, this is 50% of this value here. And here what they do is they look at the cumulative cash flow. They take 15% of it, and that's interest, right? And so that's why you get this number here. And there are two ways to think about this, about what's happening here, about this step, right? If you took out a loan in the amount of 1.8 million to fund your project, which can happen, then of course the loan has interest, and you can take it as cost of funds, this 15%, to be the interest of the loan. And if you remember from before, we had like the loan balance thing in the table when we did a table in chapter 3, I want to say, right? And we had loan balance and we computed interest. That's kind of what's happening here. We take the loan balance. Currently, I owe the bank minus 1.8 million. If I compute the interest, it's going to be 270,000, right? So that's going to be added to the amount that I owe. That's why it's negative. And therefore, I owe the bank this plus this. Then I need to add what I'm getting, which is 454,000. Okay, so if you do that, this is going to be your end balance, let's say, at the end of year 1. So this is the cumulative cash flow. And you can do the same thing again, right? This is how much I currently owe the bank, which is, of course, the principal plus the interest. I compute the interest on this, 15%. I'm going to get this value here. Now, this is how much I owe the bank. I add what I'm getting, basically, or I subtract. I mean, it depends on how you're looking at it. And I get this value here. And I continue in this way. All right. Now, this is my cumulative cash flow. And I can do the same thing. I can select the discounted payback period in the same way. So I look at the first number that's positive, and I choose that number if I'm assuming sort of discrete jumps. That's the number that's going to be my, so this 4 is going to be my discounted payback period. So this loan thing, this interest, is one way of interpreting this 15%. Another way is to look at it as opportunity cost, which hopefully you all know. I think we've covered this before, what opportunity cost is. So again, the example that I think that I gave at that time was you're currently, hopefully, listening to my lecture. So that means you could have done a number of other things, and you're sort of paying the price so let's say you could have been, I don't know, gaming at this point, or you could have been solving the homework. But instead, you chose to listen to the lecture. And so the price or the cost that you paid is the cost of the best alternative that you would have otherwise done. All right. So if you value playing games right now, early afternoon, then listening to my lecture, you sort of paid whatever the value of that activity is. That's kind of your opportunity cost. That's your price. So here, the company is committing this much in funds in this project. The company could have taken this amount and invested it to earn money elsewhere, right? It could have kept it in like a savings account, for example, and it would be constantly earning, rather than, as you see here, it's going to be operating at a loss for a while because, I mean, it just invested, and then it will take some time for it to get its money back, right? And so because of that, you can estimate this opportunity cost, and you can think about this cost of funds as the cost of sort of using the money that you could have otherwise just kept in a savings account. All right, so that's sort of another interpretation. And I find these concepts a little bit strange because they're not very tangible. I mean, maybe the loan one is a little bit more tangible, but of course you may be wondering like why. So loans make sense, like I'm paying interest on the loan, but once I paid back the loan, once I'm in the positive, why am I still computing 15%? Right, so that was a question that I had that wasn't clear. In fact, we're going to see later a better interpretation of this cost of funds business. Okay, so that's why I think it's better to go through it now in this discounted payback period approach, so you can be familiar with the term, and then we're going to see later how we can interpret this a little bit better towards the end of this chapter. Okay, so this is how we do it. There's another approach which I think is easier. At least I found it easier myself. And in fact, it's kind of what I expected. So it says here that this is based on cumulative discounted cash flows. Well, why don't I take the cash flow? I take this column here. I discount them using the interest rate. So I essentially find the present value of each of the payments, and then I compute the cumulative. And then I find the discounted payback period. And in fact, that's exactly what I did. Okay. So before I do that, so again, you could do the same thing that we did before. So if you're assuming a continuous stream, so you're assuming this amount is distributed evenly throughout the year, you can do the same thing that we've done before to find exactly where the point at which you cross zero is. Except in this case, you have to be a little bit careful because remember, this is how much you owe the bank, right? At the end of time 3, really. And so you have to take that into account. So this is why you're adding these two values here. And then this is your income at time period 4. So you're standing here just before you receive this payment, in a way, is this plus this. Okay, of course, the absolute value. You're trying to figure out how much you need to make up in order to reach 0. Okay, and then you get this amount, and so that's why you divide by this amount. All right, and you do that, you find 0.56, and then you can add 3, of course, which is here, because this gives you what happens between 3 and 4, this 0.56, and so you need to add the 3, and that gives you 3.56 years. And what we're actually going to see is that using the other approach, if you're confused about like this number here, it's not super clear. I encourage you, first of all, to think about this later because of time. But I'll show you the other approach. It becomes maybe a little bit clearer, and we get exactly the same answer. So this is the other approach. I copy my cash flow exactly as I did before. So this is just from the statement of the problem. I discount my cash flows, which means I compute the present value using 15%. So that means I take this. I mean, this is at time 0, so I don't have to do anything. Here I need to discount, which means I multiply by 1 plus 0.15 to the power 1, and so on. So I discount all of these cash flows. Right? Sorry, this is minus 1, not 1. Right? It's discounting, so the exponent is negative. Okay? But basically, you find the present value because you're going from future to present. You're going right to left, so the exponent is negative. Okay? And this is what these values are. Now I compute the cumulative discounted cash flow. So again, for example, this value here is going to be the sum of the first 3 values, and so on. And so you see here, our discounted payback period, assuming discrete jumps, is at time period 4. That's the first positive number. Let's see if we get the same answer now if we try to find exactly when it happens, if we're assuming that we're getting this amount evenly sort of across the year. And in fact, the way you do that is exactly what we did before for the conventional payback period approach. I need to make up this amount, absolute value, right? This is how much I need to get to 0, and I'm getting this much. So the fraction of the year that I need in order to make this amount up is 0.56, which, even though we're using different numbers here, it turns out we get the exact same answer. And therefore, I add, of course, the 3, which is not shown here. So I get 3.56 years. That is my discounted payback period value. Okay, so I think this is a little bit clearer. It doesn't consider that cost of funds business, but that has a nice interpretation, I think, that we're going to see later. So you can pick whatever approach you like. You can think about this another way, by the way, this approach here. If it's not super clear, one way you can think about it is, imagine you have this cash flow. I don't know, so you have an investment, then you have some incomes, which I'm just going to draw some arrows. If I take this payment here, I move it forward. I know what I need to do. I need to multiply by 1 plus 0.15, right? This is forward, so the exponent is positive. And then I add the payment that I'm getting. Okay, so at time period 1. That actually gives you exactly this value here. So if you don't like the business of splitting the interest here and indicating 0.15, you can think about it exactly as we did before, step by step. You move this 1 time period ahead, you compute what the value is. You move it 1 time period ahead, again, you move the total now. 1 time period ahead, you compute what the value is, you're going to get this number here. Okay? And so I think that's another way of looking at this problem, at least conceptually. I haven't really done it, I think, but I can see here at least the first value, you're going to get the same number, and I imagine the second one as well. Yeah, I think you will, because it's basically doing the same thing, right? You're multiplying by 0.15, and then you're adding to this value here. Right? So that's kind of like taking this number, multiplying it by 1.15, right? Same thing. And then, of course, you need to add the amount that you get at that time period. Okay? So that's another way of doing the problem. All right, so the upshot, the summary, is that payback period approaches can be used to screen projects, and they mostly capture liquidity, how soon you will get your funds back, but they don't capture profitability, and we need to fix that. We need a measurement that sort of captures profitability, and that's what the present worth analysis tries to do. And so we have a few minutes, so I'm just going to start this, and hopefully you'll see that it's nothing different from what we did in chapter 2 and 3. Not so much 4, maybe just 2 and 3. So payback method was widely used until like 1950, and they recognized that it had flaws, so they needed a different approach. And they had a bunch of techniques that are called discounted cash flow techniques. Of course, discounted just suggests that they take into account the time value of money, right? And one of these discounted cash flow techniques is the net present worth, or net present value. So NPW, NPV, they mean the same thing. Okay, and this is, again, trying to decide whether investing in a project is attractive. And we will use, actually, the concept of cash flow equivalence. So all of the formulas that we used before, we're going to use them here. And you'll see it's not very different. So in chapter 2, we notice that most of the time, when you're given a cash flow diagram, it is very convenient to move things to time 0. to find the present value. Sometimes f is more convenient, but 0 is a nice natural point to find the present value. So using this approach, we want to find the present value or the present worth of all the cash inflows, so any income that you get for that project, and compare it to the present value of all the cash outflows that are associated with the same project. The difference between the two is going to be the net present worth. And that tells you whether a project is an acceptable investment or not. And so you can think about this naturally. If the net present value of your income is greater than the net present value of your sort of the outflow or the cash outlay, that means you're sort of considering the time value of money and a particular interest rate I, you're making money, right? It's profitable, it's beneficial to you. So this is kind of a natural way of doing things. And you can compare two projects sort of by comparing their net present worth or their net present values. So you can pick the one that has the higher net present value because that is a more beneficial or a more profitable project for you. Firstly, we're going to look at single projects first before we compare alternatives. Remember, that was the last objective. So we're going to start with single projects. And the book breaks this down into 7 steps, but really, I mean, it's exactly what I just said. So the first step is we need to determine an interest rate. And this is a little bit of a complicated question because firms or companies, they determine their interest rates very differently depending on the project. And it's a very complicated question, and we'll see a little bit more about that in the next lecture, okay? But generally, a company, as we said, has money. Maybe it has the money on hand, maybe it doesn't, maybe it will take out a loan, but let's assume, for the sake of argument, it has the money on hand that it will invest in some project. And so typically, if it doesn't invest, that money may be put in some sort of savings account, right? So you can think about it as like an investment pool, right? So that's just money on hand. And that money is going to earn interest. And so typically, the company has a minimum attractive rate of return, which is, called MAR. So this is a term we're going to be using a lot. This is very important. So if your savings account can give you money sort of without you thinking about it at a rate of, let's say, 10%, then any project you invest in should have more than that 10% in order for it to be sort of attractive to you, right? And so that's why the MAR is the minimum attractive rate of return that you need for a project. Okay, so that's step 1, basically selecting the interest rate. We're going to discuss more about that later. So for now, we just need to find an interest rate. We need to estimate the service life of a project. So if I have a project, I need to know my horizon, like how many years is this project going to be going on for? Because I need to use that in my cash flow diagram, like when I draw, right? So is it going to be going on for 7 years, as the machine shop example was? Is it 10 years? I need to know the service life. I need to estimate the cash inflow for each period, right? So these are the incomes at each period. I need to estimate those. I need to estimate the outflow. Sometimes there is some operating costs or maintenance costs or whatever, right? Or maybe at the beginning I have to invest, right? So that's an outflow. And you estimate it, of course, over the service life that you were given. And then you determine the net cash flow for each period. So now I have these 2 arrows here. I can subtract. If this is maybe larger, then I subtract the smaller one, the bottom one, from the top one. And I get my net cash flow diagram, right? So my net cash flow is basically my cash inflow minus my cash outflow at any given time period. So, so far we haven't really said much, right? Then I need to find the present value of each net cash flow. So basically that's saying I take my cash flow, now it's net. Maybe it looks something like this. Maybe this is a little bit funny looking, but whatever. And then I need to move all of these payments to time 0, essentially finding their present value or their present worth. And I do that using the MAR, the minimum attractive rate of return, which is basically another name for interest rates. But it is specific sort of to a company and to projects. And we'll see what this MAR is actually in the next lecture. After you move them all to find the present value, of course, you need to sum them. And so their sum is that project's net present worth. And then, naturally, if the net present worth is positive, that means overall your benefits exceed or your inflow exceeds the outflow, taking into account the time value of money, then I will accept the investment. If it is negative, that means my costs exceed my benefit, so that is not a good investment, so I'll reject it. And if it's 0, of course, I'm indifferent. So 0 means nothing really happens. Or I can choose to accept it, choose to reject it. It doesn't matter to me. Okay, so this is where we'll end today. The principle, again, is to compute sort of the net surplus at n equals 0 using a given interest rate I or using the MAR. And we're going to accept if the net present worth is positive, right? Or you can write it as greater than or equal to 0 if you want to. And so this is kind of the picture that I was kind of drawing before, right? So you have outflows, you have inflows. You find everything at 0. You find the inflow at 0, you find the outflow at 0, and then you compare them and you find the net at 0. I mean, you could do this multiple ways, right? So you can move the outflows first to 0, then the inflows first, and then subtract. Or you could just move them one by one and just add them all together. I mean, it's really the same thing, right? And you find the net surplus. If it's positive, then we accept the project. If not, then we reject it, okay? So this is nothing new. It's just introducing a bunch of terms and giving a name for this sort of process when it comes to evaluating the profitability of a single project. Okay, so we'll end here. I'll take your questions after I stop recording. Other than that, see you next week for the quiz.